Good morning, Pre-Calc. Welcome to another exciting day in the world of math. So here's your do now for today. Remember, as you're coloring in the graph, remember that graph walkers always move from the left side of the graph across to the right. They can't ever go backwards. All right, so I've already got these colored in here. The graph walker is going to be going up in this green section. It can't go backwards. There's no possible way that this could be decreasing because the graph walker can't go that direction. So the blue part, decreasing. It doesn't make any difference that the shape changes partway through. It's just irrelevant. It's still decreasing. Another increasing section here in green, and then constant, meaning that the height does not change over there in red. Okay, today we're going to begin our intro to calculus. It's kind of a mini unit, and the first thing up is we're going to learn several different notations that are used in calculus and some ideas that go behind them. So today we'll be looking at interval notation. I'll use that to describe graphs in terms of whether the graph is increasing, decreasing, or constant, just like we saw in the do now. So you might remember, hopefully you remember from back there in the past, learning about function notation, which is a type of notation used in math, f of x. And part of the definition for function notation is that the function value, or the y-coordinate, is determined by the x-coordinate. Okay, that's the part we've got to pay attention to for today. The rest of the definition says every function value has only one x-coordinate that's associated with it. Still true, not quite as important for what we're doing today. So we're going to take that part of the definition of what function notation is. We're going to start that as a working definition. We're going to modify it for use with interval notation. So if we're looking at interval notation, the description of the function is determined by the x-coordinate. Okay, so descriptions, things like, for example, what we saw in the do now, whether a graph is increasing, decreasing, constant. There's some other things we could look for, but those descriptions are determined by the x-coordinate. Okay, so the only way we're going to describe functions using interval notation is by the x-coordinate. Right, so there's some things we need to pay attention to with interval notation. Only write the x-coordinates. That's the first one. Okay, the big kind of confusing and weird thing about interval notation is even though we're looking at like where graphs go up and down, and that's a description of the y-coordinate. If you're increasing, the y-coordinate's going up. If you're decreasing, the y-coordinate's going down. If you're constant, the y-coordinate stays the same, right? But when we use interval notation, the behavior or the location, the description, whatever kind of description it is, the description of the function is only determined by the x-coordinate. So that's the only thing we write down is the x-coordinate. Okay, so interval notation has two different types of brackets. That's what we use to make this sort of notation. We use brackets to say from here to here is where the graph is doing this thing. From here to here is where the graph is doing that thing. So there are round brackets or open brackets. They look like parentheses, but they're not. They look the same. It's actually the same symbol, but we're not using it as parentheses. And then there's a closed bracket or square bracket. Okay, the difference between those two things is exactly the same type of difference that you learned about before with inequalities. So the same idea with like a less than, where you say, well, it's got to be less than 3, right? So 3 is not included in that inequality statement. It's got to be smaller than 3. So the 3 is not included. That's the same idea that an open bracket or the round one does. So we would use that just at a point on the graph where, let's say the graph is increasing, right? We're not going to include the number that we're about to write down. It's going to be like right after that. The closed bracket, again, is the same idea as like when you learned with inequalities, like a less than or equal to. So if you said x is less than or equal to 3, 3 would be included as part of that inequality. Okay, if we need to include that x value on the graph, then we're going to use the square bracket or the closed bracket. Okay, when we're writing interval notation, we go from the number at the left end of the graph goes to the left side of the interval. just like when you're reading a graph, we read from the left across to the right. So when we're writing interval notation, you also start from the left side and go across to the right. So smaller numbers at the left, larger numbers at the right. Sorry, from the left to the right. And that applies also if we're using infinity, like if the graph just continues a behavior forever, positive infinity or negative infinity, depending on which side of the graph you're at. Okay, still small things like negative infinity at the very small end of the number line is going to be at the left end of our interval. And then lastly, sometimes there is more than one section of a graph that has the same description. Like in the do now, we saw there were two different places where the graph was increasing. It was increasing over here, and then again increasing over here. So if you've got these two different spots, in order to write that with interval notation, we use this symbol U, which represents the union as a way of combining two different things. And so we're going to have to put that symbol between the two sections of interval notation. Okay, so just to help kind of a little bit with the comprehension, here are just some examples of how we would write things with inequalities and how that kind of translates to interval notation. This is not a skill that we will ever do. We're not actually going to translate from inequalities to interval notation, but I think it'll help because inequalities are something we're more familiar with. So if you had this compound inequality where x is greater than or equal to 2 and less than 6 written as an inequality, to do the same thing in interval notation, we'd use the square bracket at the left side. That's where the small number goes. So the 2 starts at the left side of our interval. That's a square bracket. The square bracket does the same job as this less than or equal to symbol. And then the bigger number, the 6, that's going to go over there on the left side. And since that inequality symbol is a less than, we'd use a round bracket to say, well, the 6 is not actually included as part of this interval. It's like the stopping point, but we don't include it. Okay, so one of the reasons why mathematicians like interval notation, and there's several reasons why we use it, but one is that it's shorter. And it doesn't take up as much space on the page as using inequalities. And then obviously there's the graph. So another example, each of these graphs, so this is not from inequalities, but just as a demonstration, here's some intervals that are written with interval notation and the graphs that are associated with them. You've probably written inequality statements for graphs like this somewhere way back in the past, and I mean, who knows where, Algebra 1 or something. Okay, so let's go back to the do now. Let's do this as an example of writing interval notation for the three types of intervals that we're going to be looking at today: increasing interval, decreasing intervals, and constant interval. So let's do the increasing interval in green. So my little graph walker always starts at the left end of the graph. Where does the graph walker start to increase? Well, it looks like they've always been going uphill. We've got the little arrow there at the end of the graph, meaning that the graph behavior illustrated continues off of the graph. So really that graph walker has always, since the beginning of time, been increasing. And so we're going to say that, I'm going to get the right color here, that is negative infinity, not because it's at the bottom of the graph, but because it's at the left end, because we're only using x coordinates when we're talking about interval notation. So the very far left end of the graph, or the very far left end of the number line, is negative, and we got to go forever. So negative infinity. Okay, any type of infinity, whether it's negative or positive, always, always, always uses a round bracket, because infinity is an idea. It's not an actual number, right? Infinity means like forever, but it is not like the number that comes after 999,999,999, right? It's not an actual number. So we can't include it, which means we can't use a square bracket. So infinity always gets a round bracket. And then the interval continues until the little graph walker gets up here to the top of the hill. The x coordinate right there is -2. -2 is an actual number. It's an actual place on the graph where the graph walker can actually get to. And so we're going to include that using a square bracket. So the first increasing interval from negative infinity until -2, right? There's another part of the graph that also is increasing. We'll just jump over here, starting from the x coordinate of 2 until the x coordinate of 5, the graph is increasing that whole time. Both of those are actual places on the graph that really exist, described by real numbers. So we're going to use square brackets for both of them. Okay, so I need this letter U to combine the first interval with the second, and then my second interval from +2 until +5. So it's kind of one of the things that is confusing about interval notation is we do use that comma in there to break apart the beginning and the end of the intervals. And so sometimes they do look like coordinates if you're using round brackets. It's just something we have to get used to. It's the same symbol used for a different purpose. Okay, so decreasing. The blue section that we highlighted on the graph before, the graph Walker begins decreasing at an x coordinate of -2 and continues to decrease until an x coordinate of +2. So we're going to go -2, +2. Both of those are real places on the graph that really exist, and they're described by real numbers. So we're going to include them using square brackets. Lastly, let's look at the constant interval. So we've got this little section over here at the right end of the graph where the graph walker would be at a constant elevation, starting at that x coordinate of 5, and then continuing off the edge of the graph forever. So change colors to red. So 5 is a real place on the graph described by a real number, and it's an actual place that the graph walker actually can get to. It's right. It's not like an asymptote or a hole in the graph or something. So I'm going to include that with the square bracket. And then that interval continues until, well, forever. So positive infinity off the right end of the graph. So this doesn't mean that I'm going up. I mean, that's an easy thing to think about, that, oh, we're describing like the height or something. It's going up forever. It's not. This interval notation only uses x coordinates, so that positive infinity means that we're going to the right forever, and the far right end of the graph or the far right end of the number line is where infinitely large numbers live. So positive infinity for that reason. And then infinity always gets a round bracket because it's not an actual number, it's an idea. It means forever.